here we are then. Right, you know what to do?
Yeah.
You better look for that.
Oh.
Yeah?
No.
I'll leave it.
I'm going to tell the supervisor.
We're wasting time.
I'm going to tell him.
Look again, he says. We've been looking for over an hour. We should be getting on with it. It's not here.
Well, where is it?
It's probably gone all the way through.
And if it has, we'll never find it. We're wasting time.
Look again.
What about the job?
Use the entry scope.
Some hours later, the object of the search was found. And here it is, a 6-inch long Allen key. It was found with the aid of an intrascope inside the rotor fan. Here. It was retrieved using a magnet attached to a curved rod. Fortunately, in this particular case, the fitter working on the job had the presence of mind to declare the fact that he had lost a tool, and the supervisor, despite pressure to get on with the job, insisted that the fullest search was carried out. But things don't always turn out as well. I'm joined now by Nick Plant, who has investigated the cause of many machine failures. So, Nick, what would have been the result of this being left in the machine?
Well, the probable result would have been the ejection of the Allen key from the fan at high speed straight into the stator end winding.
And what sort of damage might that cause?
Well, we can see on these photographs here some typical damage, and the subsequent failure has completely wrecked the machine.
So, Nick, what are all these objects?
Well, they're a selection of items that have been either found in machines or of the resultant damage caused by such items in the machine.
And what about this spanner? How does a spanner cause a machine failure?
Well, a spanner very much like that was found inside a generator in many pieces that had been in the air gap between the rotor and the stator and caused severe damage to the machine.
And how do these objects get into a unit?
Well, quite obviously, someone leaves them there when they've been working on the machine. They may not realise that they've left it there, or they may have lost it and not effectively looked for it.
I can understand how solid objects like these can damage a generator. But what about little bits and pieces, like these?
Well, it's true that even small pieces like these can put a generator at risk. For instance, the gas passages in the generator rotor winding are of a size which can be blocked by something like this being blown into it. In fact, there are some areas of the generator that can be put at risk even by an item smaller than a grain of rice. And the conductor bar itself is actually made up of subconductors with small holes in like these. So you can see how easy it is for a very small object to block the subconductors. And if several of them get blocked, the bar can overheat. If the conductor bar fails, it can cause a very expensive outage.
Now, I suspect that the damage that we've seen runs into hundreds of thousands of pounds.
Well, actually, it's tens of millions of pounds. In the UK generating industry, in the last 10 years, there have been 10 serious failures.
So how are you going to put a stop to it?
We need to improve our clean condition working procedures.
How on earth do you expect to maintain clean conditions in a power station?
Well, in the case of a major overhaul, in order to prevent unauthorised entry, the first thing you do is erect a barrier around the whole of the working area. And then you clean the floor inside the area and remove any unwanted equipment. Then we erect a control area with a guardian to record and monitor all entry and exit of men and materials from the area. We also provide an anteroom for the storage of the small tools and materials that are going to be required for the job, but they too must pass through the control of the guardian. Clean condition overalls that have no pockets or zips and have elasticated cuffs must be worn in the area. Tools to be used straight away must be logged in, and the rest left in the anteroom. Materials such as nuts and bolts should also be logged in, and their actual use checked and recorded to ensure that none are accidentally left in the machine. Overshoes and tack mats must be provided to prevent swarf being walked into the clean area. It's not only foreign material left in the machine that can cause damage. Debris such as small pieces of core plate and vent spacers can become detached from the machine itself. To avoid losing tools, where possible, they should be attached with a wrist strap. When the work is completed, a detailed inspection of all areas of the machine must be carried out. This is usually the joint responsibility of the station engineer and the contractor's supervisor. Those areas which are inaccessible, including pipework, should be inspected with an intrascope. Well, this is a 500 megawatt generator that was on overhaul, costing hundreds of thousands of pounds. It was near to the end of the overhaul when a welder, working on a pipe just above the end windings, allowed his sparks to fall onto the end winding itself, setting it ablaze. Within a few minutes, the whole end winding itself was on fire, wrecking the generator. Well, any guideline can only be of a general nature, but after all, clean conditions is only a matter of common sense. All we can ask is that everyone involved is aware of the risks and the consequences of not following the procedures. What we would ask is that anyone working on a generator who mislays or loses a tool or any object must report it to their supervisor. I would say to anyone preparing a program for work on a generator that they must plan into that program the time needed to set up and operate proper clean condition procedures and consider it as an insurance against the real possibility of a major failure.